Oh,
you're muted.
Classic.
Hey. Welcome to a new episode of SDV Coffee Talk. Today with three amazing guests, actually. One is regular, Mo, Florian. So one disclaimer from my side. Everything what I say is my own opinion and has nothing to do with my employer. Let's have a short introduction round and then we can just start.
Yeah, I can start. As you say, I'm a regular. So I'm in the automotive industry for 20 years, currently SDV consultant. Been 6 years at Tesla. This is where I worked a lot with those two guys. So I'll give them the stage. I introduce myself every other month here.
Thomas, you want to go first or you want me to go first?
Sure. So my name is Thomas. As Florian mentioned, worked with these two guys at Tesla. I was there for 7 years, 13 to 20, and then I had another 4 years at Lucid, and now I'm also doing consulting in the SDV and EV space.
My name is Mo. I work with these two guys, like they said at our time at Tesla. Although they have many more years than I do there. But prior to that, I was at Ford Motor Company. And then post Tesla, Google leading Android Automotive OS integrations for automakers. And then since then, I have founded a company called Predictive Horizons, which focuses on diagnostics for automakers and service technicians and dealerships.
Cool. What is our topic today? I mean, we would like to talk about world in data. What is SDV's secret enablers actually? And I would like to just start a little bit and go into this direction. I think in the world of SDV, I mean, with connected cars 24/7, we have a lot of data which is coming from the vehicle to cloud and also from cloud to vehicle. I think probably we can just start how to deal with that. I mean, are we ready for that? I mean, having so much data in this sector, which is not used to deal actually with so much data. What do you think about that?
So what I would like to say to start is like there are different approaches to that. There are companies like where we are used to with Tesla and Lucid who actually use the data to a large extent. All cars are producing that data, but is it actually used or consumed? And does it really reach the people who can do the best with it, aka developers, for example? So that's one of the main observations I have right now. There's large car makers out there who do not even have a proper strategy around that.
Yeah, I think the question is also that the large car makers, all car makers need to ask themselves is what they want to use this data for. If they want to use this to improve their own product, or if they're thinking about, can I sell this data or can I sell it back to the customer somehow?
Yeah, I think that's a huge question. I was going to say, I think one of the things that people don't realize, so Thomas and I both worked in service engineering at Tesla. And one of the things that people don't realize is actually we were the largest consumer of that data. We made the most use out of it for the whole company because we were dealing with post-launch issues. So it has a really huge benefit. I think one of the misconceptions is that I would say general about like Silicon Valley is that this data is kind of being sold and stuff like that. It's not really like that. It's more being used to really improve the product. But one of the biggest challenges, I think, for established automakers as compared to like a Tesla or Rivian is the scale that you're operating at. Whereas especially with a company that's just starting out, that maybe doesn't have as many vehicles on the road and doesn't have the legacy of multiple years of models and millions of vehicles on the road, it can be quite challenging for those automakers to collect and make use out of the data. And so like even in our company right now, when we talk to automakers, there's always a question of what should we collect? How much of it should we collect? And when do we throw it away when we don't need it anymore? And those are all really huge questions that the industry is grappling with right now.
Yeah, and I think that's a good point, because I think at our previous Tesla, when we started this off, it was really early times for collecting this kind of data over the air, from vehicles directly and from customer vehicles. And we didn't know either what we need to collect, but it was a smaller fleet. And as we went along and we're able to start figuring out problems, we figured out, hey, what kind of data do we want, and what granularity do we want it? Do we want to aggregate it first?
And I think that's a great.
We figured that out.
That's a great point, right? We not only collected it over the air, we also configured it over the air. So it was not carved in stone. It's like, this is the data we are collecting. So every few weeks we had a new focus point. We brought out a new feature, and we'd add new data collection. And then after a while, that feature is like frozen, if you will, and we can reduce the amount of data for that particular feature. The car is creating so much information, but not all of that is actually useful, right? Fatih, you mentioned in the pre-chat, it's like data is not equal or proportional to information, right?
Exactly.
One very simple example was exterior temperature. It goes through the canvas at 10 hertz, but you don't have any changes in exterior temperature within milliseconds, right? So we could just like easily filter that down to 0.1 hertz or even 0.001 or whatever it is, and still have the full value. On other signals, for example, the accelerator pedal position, and we brought up that example a few times, there you need the highest resolution. So you have to be smart about what data you are collecting, because you're generating actually much more data than you need.
Yeah, and that's actually something that we work on every day at Predictive Horizons, is like, how do we build the tools that make at least give automakers the ability to be able to build those kinds of programs? Because that's really a huge challenge right now, is like, a lot of times folks think that you just have to collect everything, and you definitely don't want to do that, because it's not all useful. But also thinking about, like, do you start collecting things like when the data changes? Are there other kind of some signals, for example, may be useful to collect at a rate of 1 hertz, for example. Some you might want a higher resolution, and so those are things that I think, like, you need, instead of thinking about building a program on what to collect. I think it's better if you're working in the auto industry to be thinking about, how do I collect this, and how do I make it so that I can, in a very agile way, be able to like pick and choose what signals that I need for the time being. The one last thing I'll say too is that a lot of times, especially when you put a vehicle out into the world, you don't really realize how it's going to be used, and so you're never going to be able to fully anticipate every single thing. That's why DTCs don't cover every single problem that you might have, and you might want to collect signals in general. So it's really about, how do you build a program internally at the company so that you can figure out how to do this in a more agile way.
Yeah, I love that you said that DTCs and freeze frames, for that matter, for those who are familiar with those. I remember before my Tesla time, we were diagnosing a steering system that had a breakdown in Eastern Siberia. And we got freeze frames that gave us the exterior temperature, the time of the day, and the voltage on the 12-volt network, right? And then basically it's like, what's the problem, right? And you cannot really say anything. So the data you want to collect has to create your digital twin, for the lack of a better word, right? So me as an engineer, if I get a problem reported, I want to be able to reproduce or understand that problem based on the data that I collect. So actually, it's so much easier than in my case. I had to fly to Siberia and try to replicate the issue over there. So we really want to be able to give the engineers as much information as we can, but in the same time, obviously, stop like creating. I heard the term data swamp, right? So not a data lake, but because you don't find anything in there, right?
Yeah, this is one problem, exactly, having data overload, sort of like this data fire hose, and you just can't consume that amount of water. And I remember when I first went to Lucid, we were just collecting massive amounts of data and way too high resolution. And I literally couldn't query that amount of data. Like, it just wasn't possible. So it became useless because I couldn't actually do anything with it until I did lots of ETL jobs and slowly brought it into a lower resolutions or aggregations.
So let me ask you that about that. Is that because a lack of understanding was that like a conscious decision to collect like that much data, or was it just like it's just aggregating whatever somebody will look at it?
With a small amount of engineering vehicles, that's where it came from. It just kept the same configuration. So with that, you really want that high granularity. You're looking at very specific individual vehicle problems. But when you go out to the entire customer fleet, you really want to look at that broad fleet-wide data and really be able to compare vehicles and see what happens across the entire fleet. So I think, yes, it came from wanting from that engineering perspective when you're still working on very early prototype vehicles.
But that's a great point, right? Depending on where your product is and what stage, you actually should adapt your data collections. You should not have like as I said earlier, carved into stone for the next 10, 20 years of products. For sure, you gotta be adaptive there.
Yeah, when you're in tens of thousands of vehicles, you can look at every single vehicle. When you're producing tens of millions, you might just want to have a cross section of or a statistical significant amount of vehicles, but you don't need to collect every piece of data from every vehicle. You just want to make sure that every configuration of vehicle is represented.
I have one question actually to the data stuff. I mean, in the classical vehicle, we didn't have so much data, but with SDV now, a huge amount of data comes actually into the picture. I mean, what is the benefit now? What will be different? I mean, to the classical vehicles, what we will get from the data out as information than to the classical ones. You know, I mean, I mean, I think this is not so clear at the moment. We just collect a lot of data, but what is at the end the benefit of that?
I let Mo answer first, but I have my own.
Okay.
We're all gunning to answer here.
It's like the biggest question. I think a lot of people think that there's some monetization in it. Really, this information is best to improve the product over time. This is the one thing that's like, so that's the big benefit. I don't think, I mean, even classical cars, not classic cars, but classical cars with classical, CAN bus networks, they still produce a lot of data. There's actually, like in our world in diagnostics, there was a very small subset of that was used. We typically didn't use normal mode messages. We used the UDS messages that were on the bus. But and those were like, there was a lot less of those. I think the big change that really comes with SDVs is the resolution of that data. In the past, we had like 50 KB of memory for DTCs and things to store. Now you have gigabytes of memory that you can store, and I think it changes from signal-based diagnostics over into more like log-based analysis. And so what we're going to be expecting, technicians to do is really to understand how to diagnose very similar to how you would diagnose like a software program today. And so I think that's the biggest change, is that there's a really high resolution. You have a lot more information. You should be able to root cause much faster than you have in the past, but the job itself is much more complicated and difficult than in the past of like, look at these 5 signal graphs and change things. That's what I think SDV does.
Yeah, it's fascinating. On one hand, we give much better tools, and AI is obviously doing its share on that as well. Yep. But also we make the product much more complex. So so in the end, the net might be almost equal. So I just came back from an HMI conference last week in Detroit, and the number one thing that everybody was putting on the top there was personalization, customization, personalization, and so on. And it's interesting to hear that from legacy car makers. And the question is like, hey, if you don't get information from me, how can you customize my experience to what I want? Short answer is you can't, right? But with the data and the interaction and so on, we can actually start learning how the customer actually uses the product rather than only telling them what to do with it, right? And then we can adjust software-driven features, but also next generation of vehicles. So exactly what Mo says, it's making it better, but from the improvement, performance, but also from the personalization and customization point of view.
Okay. But how about, for example, using the data to predict that a vehicle needs some maintenance or so, some predictive maintenance and so. I mean, this will be. I mean, I think this could be a big game changer because you can predict already things which will happen in the next weeks or days or months or so. I think this could be a big game changer in SDV because in classical vehicles you don't have this kind of predictive maintenance capabilities actually.
Yeah,
Yeah.
and let's open the horizon a little bit because we're always talking about passenger cars. The predictive maintenance is a huge factor for fleet operators and heavy duty. So where they look at total cost of ownership all over the place, and to know to predict, I need to take this truck down then, and I can do this, and it is not breaking down somewhere on the Interstate 40 in Texas. That's a gigantic difference in cost of ownership.
Yeah. From what we're seeing, so the predictive maintenance and prognostics is kind of like a key thing that we're working on. You can split these into kind of like, I guess, at least like two pillars. There's predictive maintenance, which we see a lot of people. You have a known fault, you have a known signature for how this particular part will fail. Because you've seen a few of them in the field, and then you basically can provide those signals and you know what signals to look at, and then you can build either machine learning models or even classical algorithms to actually predict those. I think that's right now the state of the art, what a lot of people are looking for. I think in the future too, given the data, the only is you should be able to kind of predict a failure prior to you even having that signature. That's really the holy grail that people are trying to get to, is before anyone notices a particular symptom.
And not just based on an hour counter or like any kind of like increment, right? So you should actually be able to understand the system well enough to really do it based on some sort of data rather than actual failure.
Yeah, we did this with the onboard charger on early Model S, where we'd collect the data from failed chargers and then look at what happened in the weeks and months leading up to that, and then with machine learning, be able to compare that data and look at signals we thought might not even be relevant, but ended up having being correlated to that problem, and then you could slowly build a model that can predict how much longer, how many more charge cycles such a charger could go through, and be able to get the problem fixed. If it's months out before it's going to fail, you can fix it the next regular maintenance, or if it's more urgent, you can send someone out there.
Yeah, that's a fantastic example. I'd like to also bring up the other way around to look at the parts which are not breaking and see how far are they away from breaking, because we're, as I mentioned in other talks before, we are over engineering our product because we don't know how long it will last. And we have an expected lifetime, which might be 17 or 19 years, but maybe the product we engineered lasts 50 years, and it's like crazy over-engineered and therefore overpriced. And therefore, if we actually start learning the real-world use and look at those traces or signatures or however you want to call it, we can actually, the next generation of hardware can actually be influenced by the information we have. And I brought up the example of the front trunk latch, and now we have Thomas here, who is the data guy behind it. So we found out when looking at the data that the front trunk is utilized way less in Tesla cars than we anticipated. I mean, we're talking orders of magnitude. And therefore, a redesign of the latch can actually be proposed in our example and can save dollars per car, rather than just having this over-engineered thing that will last for 120 years, but it's not utilized, right?
Yeah, because maybe to tell the quick background is that the Tesla has an extra trunk in the front, the frunk, and we expected people to use this just as often as they would the rear trunk, but having all the data, I was able to just look at how often is this trunk being used, how often are people opening that. And we saw what I thought was kind of fun. The first 3 months of ownership, people were using this really frequently because people were probably excited. Wow, cool! I've got this.
Or showed it to their friends.
Exactly, showed it off, and then after 3 months, everyone really dropped off dramatically in the usage. Why? Because it's a little more annoying than the rear trunk. It's
Okay.
not electric.
Yeah, and you have
And-
your tire kit in the front trunk and your mobile charger. You don't use either unless something goes wrong. And Thomas, I don't know if I ever told you, but I realized when I sold my Model 3, I took the tire kit out of the front trunk, and I realized I haven't opened that in 4.5 years. So
Right. Wow, that's a really long time.
yeah.
But yeah, like you said,
Martin, there was a comment now. Sorry.
Redesign the latch and save a lot of money on production costs.
Exactly. Yeah, so this comment is great because we wanted to pivot in that direction of discussion anyway, right?
Exactly. And with data collection comes challenges with local laws. I mean, especially in Germany or in Europe, and we have different, very heavy laws regarding data privacy. I think this, makes especially the German OEMs or European OEMs, a lot of complex software to consider all the regulations and so on. Yeah, probably we can talk about this a little bit more in detail. What do you think? And I mean, also both worlds, Europe and the US, for example. Probably you could just bring some examples.
I actually worked on the GDPR problem at Tesla, and I don't want to call it a problem. It was actually, I think in general, I might have an alternative view on it. I thought it was actually really good. It challenged our team to come up with some innovative solutions for how we would diagnose vehicles with this data that we knew was so valuable, and yet keep the customer's privacy private. So I think in general, like I haven't seen really a negative impact on the consumer in terms of some of these laws. I might be in the minority on this. I think it's only a positive impact to have those kinds of challenges. It just means that you have to find a technical solution to a particular problem. At Tesla, we figured out a way to keep diagnosing vehicles on the road while anonymizing the data that was coming up into the cloud. I worked on that with with Joe from the Fleet Analytics team, and Thomas, you were part of that too. We worked on it together. But yeah, in general, I think yes, it's a technical challenge, but it's not an impossible thing to go around and still maintain the benefits to the company.
But if this is I mean, it's some kind of a innovation stopper, so to say. I mean, probably other countries like China or so don't consider this. I mean, they don't have this kind of regulations there, and they can produce much faster software and also vehicles because of this kind of lack of regulation. But in Europe, for example, we have to put a lot of attention on that and put also effort to implement this. I mean, could it be some kind of a showstopper, so to say? I mean,
I think at one point, just one thought. At one point, you just have to shift from a server-based diagnostics to a vehicle-based diagnostics, and then you actually avoid a lot of those problems. So in the first step, you had to keep it local within the government, within the country, right? So we had at Tesla, we had to build up a server for China in China because we're not allowed to take the data out. But the next step, I think, has to be that the car is doing a lot of this data analysis already on the edge, and we are seeing people working on hardware that's capable of doing that. So we're waiting for more compute for that.
Mm-hmm.
Yeah, I was going to say too. You have to remember that usually to be able to bring vehicles into a particular market, you have to meet the regulations of that market. There's even things beyond, there's the data privacy laws and things like GDPR, but now we're even seeing like international regulations like UNECE, R155 and 156, which, they also put like constraints on the automakers. So essentially everyone has to deal with it, even if you're an automaker outside of the market, in order to bring your vehicles in. So I think from that perspective, it's kind of an equal playing ground. I don't think it's necessarily harmful to innovation, but yeah, like those are the kinds of, like what Florian mentioned, are the kinds of innovations that you would see, things being done more on edge rather than bringing things back to the server. It's just technical challenges, not necessarily
I think you still need pseudonymized data offline or offboard to be able to develop the onboard diagnostic. So yeah, you can do a lot with edge computing, but you need to collect the data from a large fleet so that you can actually do predictive maintenance, because you're going to need actual failures happening and what leads up to that from a large amount of vehicles. So I think it's still important to have that. But what you need to keep in mind is that the automaker doesn't actually care about the individual car. What they care about is the large amount of vehicles and the data collected from there. So it can be anonymous and something consumers shouldn't.
I just had a comment, if you can put that up from Brian. Sorry, Thomas.
The first one? This one?
No, the second one.
The second one, okay.
Correct. That goes along with actually what I was saying, right? So don't only collect raw data, actually be smart about and smart in a like edge computing smart way. How you
but in this case, you need a lot of the data processing on the vehicle, right? I mean, this is also a lot of, I mean, problem. I think nowadays, if you look on ECUs and how ECUs, I mean, you don't have so much compute power there. And I don't know how to deal with this amount of data. I mean, it's also clear, even if you have connectivity, I mean, this amount of data you can never stream to cloud. This will be not able. I mean, you have to filter the data somehow, evaluate onboard or so. But I don't know how to deal actually on the technical side with this huge amount of compute you need actually for doing this.
I mean, for multiple reasons you need to do it, right? So for data, volume is one, policy and regulation is the other one. And this, I mean, as we speak, there are companies developing this compute power. Moore's law applies also to automotive hardware. It's just a little delayed.
So from in terms of like the challenge, so the SoCs that are in vehicles these days, like new vehicles, are actually quite powerful. Like the Qualcomm chipsets are very, very powerful, can actually do quite a lot. And same thing with some of the other chip producers. The problem that with kind of like with the automotive is the length of time that the vehicle is like in the field. So it's like if you might have a very powerful CPU right now that can collect everything and process anything that you wanted, but in 10 years time, that's not necessarily going to be the case. So that's from my perspective, that's really the biggest challenge, is to make sure that like if you're building anything in terms of like software that's going to be on board processing this data, it has to be minimal and like be able to be supported for 10 years time.
It is an interesting observation. I remember also from the Tesla days when we debated the capability of the CAN bus and it's not enough. And then we actually sat down and we really looked in what's going on there. And it's just software developers, and that's not an offense, but software developers are wasteful with resources. This is just in their blood, right? I remember at my Conti times, they changed everything to a 32-bit architecture, and they coded flags in 32-bit, which is, because you can. So if you really sit down and really go down to what you need, I think there's a lot of reduction you can already have.
I'll tell you a story. I'm not going to say from where, but I've had multiple arguments with people about the amount of resource consumption of certain applications. And some of the philosophy that I've heard was, if you don't use all of the resources that you have access to, then you're being wasteful, right? Like, I'm like, no, that's not how it works in automotive. You have to use as little resources as you can, because you have to make it last a long time, and you have to expect that there's software bloat every single year.
Okay. Yeah, there's going to be other colleagues who also want some of those resources. You're not alone.
Yeah.
Yeah. I mean, regarding the amount of data, I mean, we have, and this pre-processing on the vehicle, do we have already some standards in place, actually? I mean, because if every OEM does it in a different way, then I think we will have in future also difficulties to share services, on the cloud. Sure. I mean, that there will be companies providing, for example, some backend services, which car makers can, so to say, use it. I mean, are there any standards at the moment? I'm not aware. I mean,
that's where SOVD comes into play. Service-oriented vehicle diagnostics, basically probably the successor of OBD2, and it's an ASAM standard, and that basically defines how this. When they say service-oriented, basically it's like an OTA service that you send requests to the car, collect me this and that information, and format it accordingly and send it back. And that we see starting to get adopted. And I guess Mo has much deeper insight into that.
Maybe not as much as you do, but like yeah, like we've been looking at SOVD. There's some challenge. I think SOVD more. To me, I look at it as more like an architecture change. It's not necessarily. It doesn't, as far as I know, it doesn't necessarily talk about like what's on board and what's off board. It does push a lot more actually off board, like in terms of like access to APIs and things like that. But it is. I definitely see it as kind of the successor to OBD and the future of diagnostics. So yeah, it'll be interesting to see where it goes and like who implements it first and so on.
Yeah, so the thing is, OBD1 was very proprietary, right? It was, every car maker had their own, and so I cannot just go to an open service and ask them, a neutral service station, right? But now with OBD2, I can take any car to any dealership or any service, and they can read out my check engine light or whatever it is, right? And so I think SOVD is at least the idea that becomes the same thing for SDVs.
okay.
Yeah,
Okay.
and it does. By the way, it does have the capability to like stream logs and things like that.
Exactly.
That
Yeah.
you don't have on the OBD and the CAN side. It does make so like one of the things that's been broken in vehicle communication for a long time is the OSI model has been completely broken for a long time. A lot of times as a developer, so if you're working in diagnostics, you're constantly thinking of CAN frames and how do I stitch things together and how to, and SOVD like kind of takes all that away so that you're just basically working with like REST-based services, which is quite nice. And even, it does feel like it's more of an opening by the industry into kind of what's going on in the vehicle. Even OBD was, it was mandated through the Clean Air Act. And and essentially like the only things that automakers have to kind of expose through OBD are the emissions related signals. Some out of the goodness of their hearts like added more, but most of them just like met the exact specification. SOVD definitely like it feels like there's going to be more of an opening to the rest of these diagnostic signals. People don't realize that if you're a startup and you want let's say you want to build a scan tool, it could cost you like a few $100,000 to get access to all the signals to be able to build something right now. Hopefully we'll see more of an opening in the future.
I mean, if we have so much data, for example, I mean, I think a new business area starts growing, with this data. How can OEMs, for example, use this data to make business out of, do you have any ideas on that? I mean, because having this data doesn't bring any value, actually. You have to put it in some kind of, package
put a ribbon around
that people can consume.
So it's interesting, Fatih. You see, our feedback is very clear. It's not about selling data to a third party. That's not the first, second, it's not even the third approach, right? The first approach is I want to know how is my product used to improve it. Both on the functionality side of things, but also on the longevity engineering side of things, right? So I really learn much more. This is what I say. Usually, as an engineer, you only get feedback when your part breaks. You get a return part, right? Nobody is bringing back the car to check it out before they put it on a junkyard in 15 years, and you can check how well it was used over the years. So with data, you can do that now. You can monitor.
But are you sure that this data goes back to the developers? Actually, I don't think so.
That is a very that's a very good point.
Yes.
It was just wearing the Tesla glasses, right? So because at Tesla, everybody in R&D has access to that data, and they have anonymized, right? So I don't know who is the creator of the data, but I can actually look at statistics the same as I can look at individual cars. When I see a problem, I can analyze it based on that, right? Is that the case in other car companies? I don't think so. For legacy car makers. I don't know. I'll let Thomas comment on Lucid and also on his current job. He probably has a little bit more visibility in legacy car makers.
Lucid is sort of trying to follow the same methods as Tesla and has a lot of those same people working towards the same goal. What I've sort of seen across the other European automakers is they'll try to go for that, but since they're not, they'll create these campaigns where they'll say, like, I think we might have a problem in this area, so let's start collecting data on it now, which means that first that collection algorithm needs to be developed, then it needs to be pushed out to the vehicles, then they start collecting. So now, maybe 2-3 months have passed since a problem has been suspected, and they might not even be collecting the right data yet. Well, if you're constantly collecting that data and you see in your service centers a couple of problems that are popping up, and you want to know how bad is this in the field? Like, does all of the fleet have it? Is this like an isolated issue, or do 2% of the fleet have it? So I think that's where the value comes in, because traditionally you'd have to go, if you find a problem like that in a couple of vehicles, you'd have to do a huge recall, bring in the entire fleet back to the shop and look at it. And this way you can figure out, hey, these, 1% specific of the fleet have this issue, and we can go ahead and fix it. And that cost alone, the reputation as well as the actual cost of looking at the vehicle is huge.
Yeah, targeted recalls, definitely. Yeah.
Yes, that's actually the game changer, I think, is how you see a lot of the recalls that are happening right now. I know recall is like a bad word, but it's like we're talking like massive recalls that are happening, and a lot of times, when you're recalling a vehicle, you're just like, oh, I know that vehicles produced in this plant from this date to this date have this problem. Recall every car rather than look at the specific things. That's huge. The other thing I would say that was really different about Tesla coming from Ford was that the service engineering organization that was handling this is actually part of the firmware team.
Yes.
And so we had direct access to the engineers that were building the features and could give feedback immediately because we're all under the same. It was all under the same organization.
Same room, actually, for that matter.
What's that?
In the same room, even.
In the same room, yeah, exactly. We had the same Friday meeting every week, and so we could talk to each other. That's a bit of a challenge when in the larger organizations and how you feed that information back. But it's clear, like from our experiences, like the biggest value is really improving the product. That could be new features, but that could also be just quality improvements.
Yeah.
I mean, you mean that we go in the direction of data-driven feature development, so to say, that features are developed backed by data. And because nowadays, when I look, usually we have some UX researchers, and UX designers that just design some features and based on this research, but not on real data, actually. I mean, which is coming from the fleet.
Yes.
And this would be a game changer, so to say. I mean, if we consider the data which is coming back to the organization, that you really look, okay, which buttons are pressed, which like this trunk topic in Tesla, that you really look into the feature if it's used actually. If it's not used, you put your focus on a different thing and develop which is more needed by the customer.
Yeah, you can go even further if you see patterns. So, for example, if you see that people always, and in a large group, always open something and then swipe it away, then maybe your design of the UI was wrong if they immediately close something, or if they always click 3 times in the wrong and then end up all in the same thing. So we usually talk about embedded data, but the UI user pattern is actually very, very valuable. And yes, there are focus groups. I've never been in one, so I have a lot of feedback. And that's the other thing. I have a lot of feedback about my car, and I don't currently have a channel to provide that feedback.
Okay. I mean, there's one problem which is highlighted by Nizar, actually. I mean, this this incident, you heard about that Volkswagen had this configuration issue with the backend, and a lot of data is actually was leaked.
Yeah.
And I think this is a big issue now with the OEMs, which are not used to such things actually, because they're not a software company by definition.
That's exactly my answer. Yeah.
This is, I think, this is a big issue actually. This experience, lack of experience, how to deal with actually data as as a product or whatever, something you have to protect.
Yeah, now you run into malicious attackers who are doing that for a while, and they are professionals in what they're doing, unfortunately. And you basically, the car makers are great mechanical engineers, but they are totally exposed on the data side, right? And the ones who take that data, breach it or steal it, they're kind of like, pardon my French, laughing their ass off because it's so easy.
There's when we're talking about kind of like this type of information, whether it's collecting it or even things like SOVD, because SOVD actually, it allows you communication with the vehicle, and that could be there's a huge area of study on how to secure vehicles there. I think it's important that anyone who's considering building a program around whether it's data collection or remote diagnostics or any of this kind of stuff, that you also, alongside with it, also build a security program that can ensure at least, like, one, you're securing everything and as much as you possibly can, and you've thought of everything up front. But two, you also have an incident response. Like, there's a way that you can actually stop the bleeding very quickly and then reel things back in. But this is a very real thing that we're going to be dealing with no matter what.
So not for this case, but for on-vehicle security breaches or cyber attacks. That's actually really where we have to go. We have to have the system intelligent enough to see and understand if there's something happening, and then actually send out information or react on it. Because it is absolutely impossible to foresee every cyber attack that will happen in the next 16 years or whatever your car is out there. So the car has to, A, be updated continuously, but B, also has to be fitted with some sort of understanding when a cyber attack happens to it.
Yeah, and I would say that the last thing I wanted to mention is that there's challenges beyond what we currently think about. So we were talking earlier about, like, okay, some of this new data is like logs. Well, developers love logging things, and they may log things that they shouldn't, like GPS coordinates or
phone numbers dialed or something like this. Right?
So, like, these, as companies are kind of thinking more and more through bringing these kinds of programs up, even on vehicles. So, like, even if you think, like, I'll just take an example. Let's say that there's a very leaky log happening somewhere, and there's remote access to the vehicle to pull logs. Like, all of a sudden, that problem that you thought was an onboard problem is, like, now it's a major problem for the company. So doing things like having a program in place that can review the logs and everything that people have been putting in it prior to releasing, making sure log levels are set to the right level. These are, like, really important topics that need to be discussed internally.
Yeah, and Fatih, here in the US, you have something called the Right to Repair Act. I don't know if you heard about that, but by law, you have to make your car data, to an extent, available to open and not brand-related service and dealerships. And so it's a little bit of like a challenge, right? So on one hand, you have this capability and you want to secure it, and on the other hand, you have to provide it. So you have to find some sort of, like, a golden middle there.
But what do you think, Mo? We were talking earlier about GDPR, and you were saying that it's also sort of an opportunity or an engineering challenge to do that properly. But also, I think by following those rules, you're going to collect data in a way that a breach isn't quite as dangerous as if you just logged everything and didn't care about data privacy.
Yeah, I think that's why I'm actually in favor of those kinds of regulations. They do provide technical challenges, but specifically in that scenario, it makes you stop and think about what am I actually logging, and what things am I putting in place, especially in the case of an SDV. It's a little bit harder to do that on a vehicle that just has a CAN bus. You're just looking at signals. But in the case of an SDV where you have logs and people put PII information in their log entries because they're debugging something, that GDPR is really good for things like that.
I would like to talk actually about another topic. Autonomous driving. This is very popular in the automotive sector. Every OEM wants to reach actually level 4 and whatever. This was very challenging before, I think, because lack of data and whatever, it was difficult to handle. But will this change in the era of SDV? Because you have so much data, if you're on the road, from sensors, from cameras, and so on. Will this change or accelerate this, that we will reach this level 4 autonomous driving, actually?
So, the SOTIF standard calls it area 3, I believe, which is the unknown unsafe scenarios. And this is the huge challenge. So if you want to solve that, you have to make every scenario known and to classify that as safe or unsafe. And it's unsafe, you have to put mitigation and validation on it. And as a result, your validation cycles are huge. It's like you have to basically consider each and everything, right? And not diving into the idea how AVs shall be developed in the future and how intelligent they should act on unknown scenarios. But the fact that you are continuously looking at the data and learning how your vehicle behaves in certain scenarios is a huge game changer. Before that, you had to fit in expensive data loggers. I'm talking about like 10, 15 years back. Right? You had expensive data loggers, like $20,000 per car, and you had to drive millions of miles with a test fleet, and it takes forever. And that's slowing it down immensely. Now, the cars being data loggers basically themselves, that's a huge improvement. I'm not saying you should let your customers test your features and functionality, right? We're talking about validation, right? So we're talking about add-on unknown scenarios, make them known and learn out of them.
Okay. You think that it will accelerate somehow this feature of autonomous driving with data?
Yeah, because it's about identifying all those corner cases, that 0.01%, that it's hard to figure those out. And if you have a huge fleet out there of actual real world driving, you can find more and more of those corner cases, identify them on board, and then send them into the cloud to train your model on those.
And the fine tuning, right? So your car might behave in a certain way, and that's fair, right? It's safe, it's okay, but it is not feeling like human drivers would do. So you start to learn more out of your data, and you can actually fine tune the behavior. Waymo just did that last week. They actually made the car slightly more aggressive because they realized the way they are programmed right now, they get stuck at stop signs. A friend of mine got stuck at a stop sign for almost 45 minutes in Los Angeles because there was no opening, and the car was waiting for an opening exactly this long or something like this. So in the end, he actually went out of the car and stopped the traffic so his Waymo could go around the corner.
Okay. Okay, but do you really, this is now not related to data, but do you really believe that we will reach L4 autonomous driving at all? I
think we're there already.
Without any steering wheel? No. Well, you don't have any steering wheel anymore.
We have Zoox providing autonomous rides here in Las Vegas.
Oh, really?
There's no steering wheel. It looks like a telegondola on wheels. It works.
Okay.
Yeah.
Okay.
I'm in a beta test program for them. It works great. And it's no steering wheel. When you drive the Waymos, the only reason why the Waymos have a steering wheel is, I think, because the cars were built like that, not because they need one.
Okay.
Have you, Dr. Takim, have you taken a ride in the Waymo at all or anything like that? Oh, you should try it. It's amazing.
Here in Europe, it's not possible. In Europe, regulations are so difficult that no OEM is actually able to release such cars in the traffic. This is not possible. But I have I have a problem with this kind of autonomous driving because at the end, if you fully trust on the technology and the technology fails for some reason, you pay with your life actually at the end.
Yeah, but I have much higher concern that my Uber driver fails than that the Waymo technology fails.
Really?
Absolutely, especially here.
Okay.
Technology is built redundant with the hardware and the software. There's redundancy in there. But yeah, like you said, I don't drive with 2 Uber drivers in case one passes out.
Yeah, or had a bad day. I mean, I had once an Uber driver who wanted to beat us up because he must have had some issue at home, or I don't know. And that doesn't happen with an autonomous vehicle.
Yeah, I don't know. I'm not really sure if people will accept this. I mean, probably the technology is ready, but
see,
it's
Fatih,
not so easy.
No, it's the question of scale. If you go to San Francisco, the people are this is normal. You take a Waymo if you want to go out for dinner, or they send the kids with a Waymo to the soccer practice or something like that, without any parents in there. It's absolutely normal, and it starts. But the challenge is, and we swiping a little bit the topic, but the challenge is the ODD, right? So and that's why it takes so long. They need to learn and collect a lot of data before they add a new ODD, operational design domain, like a new city, and they're doing that. So it takes some time, and it will actually scale exponentially. But in 5 years, I think that's standard in all major cities in the US, and in 10 years, it will be basically general.
I'm not really sure. Europe, I'm not so sure.
You have Moya. Moya are working on that.
Yeah,
I don't know.
Personally, I think that like for things like ride sharing, you will see a lot of it. I think for personal ownership, like to be an L4, I think that will be like people who own their vehicles. That'll take a little bit longer. I think the biggest question is really the liability question. Is if it does, you're right. Actually, if it, who's going to take liability for an accident, and it's one of the things that I think it really prevents the industry from going full blown into it.
That's why you have level 2 plus.
Yeah, exactly right. but from a technical perspective, like I think that from a technical perspective, we're already there, right? Like there's already level 4 and 5 that are level 4 that are available to consumers.
Okay. Yeah. There is actually one. I did know that Uber Momentum will launch level 4 autonomous vehicle testing in Munich. I cannot believe this actually. But yeah, why not? Germany is very strict. Let's see if this will work out. I mean, yeah.
Yeah. I think Fatih, if no human would ever have driven a car, and you would come up with the idea to give somebody after 10 hours of training a license to drive wherever they want with a car with over 3 tons of weight and 800 horsepower, you would say this is absolutely crazy. Of course, I go with the autonomous vehicle, which was developed by hundreds of engineers and has millions of hours of validation on it. But we are used to for 100 years that we have like everybody who wants to can just drive around with a gigantic amount of steel and a lot of horsepower.
Yeah.
It's just
I don't know. It's difficult.
You will get used to it. Don't worry, you get.
I think that change is you go ahead and you take an autonomous vehicle as a rideshare program once. First time you're nervous and amazed, and after that you take it a few more times and you realize, nope, this works well.
Yeah.
Okay.
I actually took my father and mother-in-law on a Waymo. They were like blown away.
in a good way.
Yeah, good way. Yeah.
So whoever comes over for CES to Las Vegas, so Zoox is free to test right now. It's a beta program, but everybody can download the app and just register for it, and they give you free rides on this trip. Give it a try.
Yeah, probably just a teaser from my side. I mean, the next episode will be on CES. I'm with Florian. Florian's organizing the next coffee talk from there. I mean, if you
maybe we should include the Zoox ride in there. Let's see how it's probably getting crowded. Yeah, because it's getting crowded. But let's see how we do it. Yeah,
I think we are reaching the end of the episode. Any final words from your side? I mean, we're reaching also 2025. If you like.
Want to conclude the year.
Just a couple of sentences if you would like.
I mean, I think to add to the original topic of this talk, which is the data and stuff, right? So be smart about creating data and collecting data. B, don't be hesitant to do it in the right way. And C, don't see it as a way to make immediate money out of it, but to improve your product.
Yeah, I would second that.
Yeah, especially the third point. I feel like the traditional OEMs are way too focused on how can I monetize this, and that's also what'll end up scaring the
Exactly.
consumer. People are selling my data. Nobody wants their data sold, but everyone wants their product improved, monitored, that it's safe, and that I'm not going to break down.
Yep.
Okay, then let's conclude. I would say thanks for joining. Thanks, Florian, Thomas, Mo, for this interesting session. And yeah, this is the last episode of 2025. Hopefully, we'll see you next year in 2026. And yeah, Happy New Year. See
Merry
you.
Christmas.
Thank you.
Happy holidays.